Now what I'm going to show you next is to add the receiver so we can get back our original message so we can feed it to a speaker, for example. So here we have the same type of setup for the transmitter, a message signal generator, a carrier wave which represents our radio station, and our transmitter. So all this is the transmitter. These, you can think of these as wires or the atmosphere being propagated from the transmitter to our receiver. In a sense, our receiver consists of two parts which you'll study in detail in many of your courses. We'll look at the receiver, which is basically another multiplier, same multiplier as we did in the transmitter, and we have to use the same carrier signal at the receiver. Now you can know that if the transmitter and receiver are like 1,000 miles apart, we can't use a 1,000-mile wire. Basically what we use is a phase lock loop, which will be studied in your electronics courses and in your communication courses as well. But you don't need to worry about it. I just want to illustrate the concept of how we capture or extract the message from the carrier signal with this modulator. And then we have a low pass filter, which you will be studying in your electronic courses, but in essence this is used to capture, to separate the message from the carrier. And here we have the display. So you can see on the top display will be our message. The second display will be our carrier. The third is what's being injected into the atmosphere and being received by the receiver. The fourth is coming out of the second multiplier. And then what we should get from this last trace is the output of this low pass filter. So you can see here I just ran the simulation, but I'll run it again. So here I go, run the simulation, generates those waveforms. I'll expand it a little bit more. So here's our message, here's our carrier, here's our transmitted signal, here's what's coming out of the second multiplier, and here's basically our message with a little bit of ripple, but you can see the idea. We're capturing our message, which is here, and you could see the same shape. Maybe a little bit of delay, but it's still in essence the same shape. Now what I could do is add a more low pass filters from here to help get rid of some of these ripples. So that's what I'll just do real quick. Copy and right click and paste, and I'm just going to add basically another low pass filter. Let me get rid of this. Take the output of this, feed it as part of the display, and then feed that there. So when you get it, should get rid of that ripple even more. I won't discuss the theory, but I just let you know that adding a more complex filter by adding two filters in series will give you a better output coming out of this second low pass filter. And you could see, let me expand this a little bit more, that we got rid of some of that ripple. There'll be some mathematics and some theory that you need to know before you understand why this gives us a better shape, and that's basically looking at signals in the frequency domain, and that will be discussed in either your second or third year courses. So hopefully this gives you an idea of the concept of a transmitter, a wire piece of a medium like the atmosphere, and the receiver, which consists of a second multiplier in terms of how to extract or demodulate the carrier signal to separate the message from the carrier wave. And here we get basically our message, and this can now be fed to a speaker, which is not a very exciting sound, but in essence it does illustrate the concept of AM modulation. Okay, let me just add by changing the message. We're going to change it to a sawtooth and see if we can get the same idea. So here's our sawtooth message. You can see there's our carrier. Here's our modulated carrier. Here's coming out of the second multiplier, and here we have our sawtooth. Notice the curve is a smoother trace right here versus a sharp one, and that's because we didn't let in too many of the frequency or harmonics associated with this triangle. What I could do is try to extend it, the cutoff frequency, but we'll talk about that in future courses. So anyway, hopefully this gives you an idea how you can change the message. You can basically capture the message. We can separate the message from the carrier using low pass filter and a second multiplier. Let me try square wave, which has a lot of harmonics, but hopefully you could see when we run it, we get, it's in essence the shape of that square wave. Alright, so again, because of the limitation of the low pass filter, we're not letting in too many of the high frequencies in order to make this a sharper point going from high to low, or from low to high and from high to low. Okay, so there's our square wave, and this is what's coming out of the second low pass filter.